Hello friends, today we talk about priority queues. So title says that priority queue means the queue is having concept of there are two pointers front and rear, and we are inserting the element from rear and remove from front. Okay, so what exactly the priority queue is? It's a different kind of queue. Actually it is a similar to the regular queue. So we are going to insert the element through rear and remove from front. Okay, so basically why it is a priority queue is a priority says that so items in priority queue are ordered by some key, which we have to maintain the order while inserting or deleting the element from the queue. Okay, it's not a regularly that we are just inserting it and removing it. It's not like that. It should maintain the order. Okay, so items with the lowest key or highest key is always at the front from where they are removed. Okay, so we have to manage that lowest and highest key according to the application. Okay, so it always at from front where they are removed. Okay, and then items then inserted in proper position. Okay, so idea behind it's the priority queue is just simple. It is a queue, but the items are ordered by a key. No doubt it should maintain the order. Then implies your position in the queue may be changed by the arrival of the new item. Yes, so according to priority the position of inserting the element into queue is getting changed. Okay, now what exactly these are the applications of priority queue. So many applications, that is scheduling queue of processor, print queue, transmit queue, there are the we have to maintain the priority here. Okay, this means this item will be in the front of queue. Okay, so we have to remove it, it is from the front. Okay, so the basically the note is that the priority is no longer FIFO. Okay, it's no longer a first in first out, because the change position of element can be changed according to priority. So you still remove from the element from the queue pointer, but insertions are governed as a priority. Okay, so this is a concept of what priority queue. So we have to make the order of element. Okay, so there are two basic operation how to access the priority keys. So remove, so the first item has priority and can be retrieved or removed quickly and return to its calling environment. Means remove function is easy. We have to remove it from front, so it requires big of one time. Okay, and when we are insert the element quickly, but we have to go in proper position. Okay, so it requires end time. Okay, so for our purpose here, implementation of data structure arrays, slow to insert, but what exactly it is? Small number of items in the queue, and where insertion speed is not crucial. Okay, so this is the smallest concept, that when we have to insert the element into queue, we have to, when we are inserting it, but in any order, let's say I'm inserting 5 4 2 then 1, but when I'm removing it, displaying it, it should be maintain the order, either ascending order or descending order. So we'll see the code in Java language. So don't bother about this language, we'll see in next semester this language, but you should clear the concept of priority queues. Okay, so just concentrate here. This is a class priority queue. Okay, so here we are creating the object of that class. Okay, so we are inserting the element, let's say in queue we are inserting 30, 50, 10, 40, and 20. Okay, so this is our element is. Okay, so element is 30, 50, 10, 40, 20. Okay, so if we have to this order we are going to store the element into it. Okay, but when we are removing it, first of all, when removing or displaying it, the queue should not be empty, that we need to check. Okay, for displaying that element, we have to maintain the order here. So this is very important concept. We have to maintain the order when removing it. So 10 will be first, 20, then 30, then 40, 50. Means we have to maintain here the ascending order, either descending order. So this is the concept of priority queue. We have to maintain the order here. Okay, so basically for that I'm giving one example of this priority queue is, suppose for example, in non-technical example I'm taking, suppose in particular, let's say in Sai temple. Okay, at the Shirdi. So every every person standing in line, they are making the normal queues. Okay, but some particular, let's say the leader person or some VIP person came to take the uh, take came to come to that मंदिर. Okay, साईं बाबा के दर्शन लेने हैं, तो वो क्या करेंगे? It should give the visiting card and they directly suddenly come into the line. मीन्स वो फर्स्ट लाइन पे आएंगे, वो फर्स्ट भगवान साई का दर्शन लेंगे और बाहर निकल जाएंगे. मीन्स they have a visiting card. Okay, so that means that some priority is given to that person. Okay, means that the priority queue, they in queue, when we have to perform any task, it should be onto the priority. So if you are maintaining the order here in case of technical, that is, if you are storing the element in randomly into queue, but when we want to remove it, it should be in the particular order. Okay, so this is a concept of what priority queues. So we have to maintain the uh, order here. Okay, so this is the concept of priority queue, so you can easily understand that. So for example, we are taking the example of stock market. Okay, so the stock market, or we can say that there is a bidding process. Always highest price is giving the highest priority. So likewise, this is the concept of priority queues. Okay, so for applications of priority queue, we can say there are many application: scheduling in queues for processor and printing a queues. Okay, so these are what applications of priority queue. Fine, so this is the concept of priority queues. Okay, so I hope everyone clear the concept of priority queue now. Thank you, dear student. So now the next part is heap sorting. How heap sort will work? Okay, so we'll focus on that part. Fine. So basically, the heap sort, yeah, sorting is an algorithm that works by first organizing the data to be sorted into special type of binary tree. Okay, so first of all, you should know what is a tree. Tree is a hierarchical structure. We can represent the tree concepts comes from natural tree. Okay, there is a root is given and number of branches are there. This is a tree concept. But binary tree means what? The binary tree is a tree at most two childs only. Okay, it has only two child. So how the heap sorting will use in binary tree, that we need to see here. Okay, so next will be, this is the definition. These are the main definition of heap sort, that is max heap and min heap. Okay, this is very important part. Okay, so what about max heap means? Store data in ascending order, no doubt. Okay, and no doubt the first node should be the greater than their child. So as a property of parent child is greater than or equal to the child of it. And minimum heap means what? Store the data in descending order as a property of the parent child is less than or equal to their childs. Okay, so but we can both max heap and min heap for ascending as well as descending purpose. So we'll see using one example so that we can clear all the concept of it. Okay, fine. So heap sort algorithm for sorting in increasing order. Okay, finally heapify the root of tree, build a max heap for the input data. Okay, so what exactly it is, we'll see. At this point, the largest item is stored at the root of the heap. Okay, and replace it with the last item of the heap, followed by reducing the size of heap. heap heapify. Okay, so how it is executed, that we'll see using example. This is one algorithm, you can easily understand that. And repeat above step until the size of heap is greater than 1. So the algorithm is clear after seeing the example of it. So we'll revise this algorithm again. Okay, so what exactly the algorithm is? We have to arrange in ascending order. So first of all, heapify the root of tree, build a max heap from the input data. How we are going to do this, we'll see using one particular example. Okay, so this is a pseudo code, we can say, of that algorithm. So we have to build max heap, we have to finding out the length of that, and how we going to exchange the element, we'll see first. Okay, and no doubt the time complexity of heap sort is big of n log n. Okay, so this is one example. Convert the following array to heap. Heap में हमें convert करना है. Okay, so the array as a complete binary tree. First of all, binary tree is a tree at most two childs, and complete binary tree means we are storing the element from left to right. Okay, left side should be filled always. Okay, except leaf node. So this is our root node is. This node we can say, this is what our root node. In case of tree, this is our root. Okay, these are the internal nodes, or we can say that child of that node. Okay, a root node, and last one will be the, this is what, internal node, and the last one is what, leaf node. So except leaf node, all nodes having left child should be filled. This is complete binary tree, we'll see in next semester, but you should know how the complete binary tree will present. Okay, so this is what the root node is here. So basically we have to tree banana hai. So binary tree, it has a two child. So first node will be the root node 16. The next node is always our Indian culture starts from left to right, so we have to filling from left first child, then right child, again one came, so one filled first left and then right, and again 19 filled left side of that tree. Okay, so how exactly we'll complete it, we'll see using next step. Okay, so we have to convert it. What we have to see, the maximum heap, max heap we have to generate. Okay, so basically this is our what original binary tree is. Okay, that we have seen ऑलरेडी. पहले क्या किया, फर्स्ट एरे इज गिवन, उसका हमने बाइनरी ट्री जनरेट किया. बाइनरी ट्री मीन्स पहला रूट आएगा, फिर उसका लेफ्ट चाइल्ड, देन राइट चाइल्ड, अगेन लेफ्ट चाइल्ड एंड राइट चाइल्ड. ओके, अकॉर्डिंग टू दैट वी हैव क्रिएटेड बाइनरी ट्री, बट इट्स नॉट अ मैक्सिम. मैक्स मीन्स मैक्सिमम वैल्यू वाला नोड रूट होना चाहिए. सो इनिशियली इट स्टार्ट फ्रॉम इट. ओके, 16 you can see, you can check using this example, you can easily understand this point. Okay, so 16 the root node. Okay, always remember that for exchanging the element, so biggest element should be what, root node. So it start from left rightmost element. So rightmost, ये देखो लास्ट में क्या था यहाँ पे 19. Okay, so no doubt 19 should be top because is a max, maximum node upper आना चाहिए. इसीलिए next step you can see easily, there is a swapping is needed. So 19 is here and 7 is here for maxi. Okay, again next next term here, the next term is 4, 12 is greater than 4. उसका रूट नोड कौन है, 12 का जो चाइल्ड नोड है उसका रूट नोड smallest है, so we need to swap. That's why in next example, next step, that is uh, 12 going to the upper side and 4 goes to the 4 is placed here. Okay, now we can see here 4 is here, 1 is here, and 12 is here. Yes, always remember that in maxim the greatest value node should be the parent node. So just concentrate here, this is 12 and 16, so no doubt before that, before the case, no doubt 4 is here and 12 is here. Now in case of this, our root node of that tree is, the root node is having 16 is smaller than 90, so we need to swap. So again we are going to swapping, 19 is here and 16 is here. Okay, so according to that we have created it. Okay, fine. So next step will be the heap sort will be what? The heap algorithm, I hope everyone clear, consists of two phases. Build a heap from an arbitrary array that we have seen and use a heap to sort the data. Okay, there are two steps to sort the element in the descending order. Use a main heap. Okay, these two terms are very important in case of heap sort. There are, we are arranging the elements in descending order means minimum heap, and the sort the elements in the increasing order or ascending order is called as a max heap. So this is our the max heap, means biggest value should be the root. In case of this is our original root, 19 is the biggest value. In case of this subtree of that original tree, okay, this is subtree, so 12 is the biggest value, biggest parent node of 1 and 4, and 16 also biggest parent node of 7. This is the example of max it is. Okay, so I hope this point is also clear to all. Okay, now we focused on one more part here, so you can easily understand that point. Okay, so next point will be, next part will be, we'll focus that part here. Okay, so everyone clear that we have arranged the in max it. Fine, so this is what, according to that, this is what maximum value, take out biggest value, that is 16. No, move to the last element to the root. Okay, so 16 अभी उसको sort करना है हमें. So जो biggest वाला value है, it is in top of the root, so we are placed in last position 19. Then next will be the what, uh, next position we can say, then 7 and 16. Okay, so move the last element to the root, yes. Then next will be the 7, no doubt 7 is not came into that. We need to swap it, hippify function we have to call. So 16 will be placed onto the first of 19. Okay, so likewise we are going to sort it. Next you can see here that 16, then 12, then 7, and then just check 16 we are taking outside. Means here you can see that root node जो रहेगा उसको हमें क्या करना है, बाहर निकालना है. So again I am revising here. So first of all 19 सबसे biggest है, we take outside. नेक्स्ट अगेन 7, 19 निकालने के बाद कौन आया, 7. सो 7 इज व्हाट, from this we have to start from leftmost and rightmost of the tree. Okay, 7 is smallest, so we just swap it. 16 is here and 7 is here. Okay, so 16 topmost होगा तो उसको हम बाहर निकालेंगे लिस्ट में से. So 16 will be goes outside, take out of the biggest, so it is placed on sorted list. Okay, again the next part will be the 4. Okay, because it start from leaf node. Okay, so 4, again we can check 4 is not the biggest value, so again we have to swap this using ipify function. We have to swap 4 and 12. So 4 will be placed with the 12 position. Okay, 12 is here. Then now we are just take out biggest value 12, so it place onto the last position. Then means in front of 16, because it's smallest than 16, right? The last one will be 1, 1 is smallest, we have to pick up the biggest value here. So again we need to swap 7, 1 की जगह पे आना चाहिए. Then 7 is there, we have to put outside, take out the biggest, then move to the last element to the root. Okay, so no doubt 1 will be go to the root, but again there is a problem, 1 is smaller than 4, so we need to swap it. So again it will go take out biggest value, that is 4. And finally the element is sorted. You can see 4 is given, and the next one will be the 1, take out of biggest 1. So this is our sorted array, that is 1, 4, 7, 12, 16, 19 in ascending order. So this is the concept of what heap sort is. Okay, so I hope everyone clear this concept, how we are going to create it. Okay, so the time complexity analysis, build heap algorithm will run in big of n time. जितने total number of elements है उतना time लगेगा. Then there are n minus 1 calls to heapify. Each call requires big of log n time, because binary tree having bytes require the log n time. Heap sort program combine build, heap program and heapify. There is, therefore it has a running time of n log n. So time complexity of this heap algorithm making big of n and log n for heapify function. So it should be a n log n. Okay, so this is the concept of what heap sorting. Thank you, dear students. I hope everyone clear the concept of priority queue and heap sorting. Thank you so much all. Please subscribe my channel. Bye.